Okay, so our last version of our linear trig functions, or linear trig equations, I should say, is dealing with some non-unit circle values. We can tell that because we're really not seeing the pi's. That's not the only reason, but that's pretty much a dead giveaway. So what we want to do is we want to get my trig function isolated. So I'm going to add 3, just like you would a regular linear equation. So sine of x, if we do negative 2.31 plus 3, that's going to end up giving me 0.69. Now this says sine of some angle is going to give me this ratio. This is a ratio. So you could think of it as the same thing as inverse sine of 0.69 is equal to x. These two are equivalent. So then we're going to take the inverse. So I'm typing this in on my calculator of 0.69. And that tells me that, well, I know it's x because x is already by itself here. So I've got x. So x equals 0.761. That's my principal value. Because the question wanted me to find all possible values, that means I have to then find the general solution because that's going to give me every single angle. So if we think about what this is actually representing, 0.76 radians is going to fall right about there. I know sine has to be positive, so it's also going to fall somewhere in the second quadrant. Well, the reference angle would be the exact same, so that's where that pi minus 0.761, that's going to come in for the second part. So I'm going to type that in, and that gives me 2.381. And remember, so this is the first one. We could go around this circle an infinite number of times. We could go around again and again. Same thing for this location. So we represent that by putting my 2 pi in. This is my general solution. So you guys like these. If we wanted to actually answer the question, you just did actually. So that right there would give me every possible value for this linear trig equation.